Okay, I'm going to do all that again. So this is the standard form of sine and cosine. They will not, sine and cosine will both not be on the graph. Only one of these functions will be used. Amplitude is the absolute value of this number in front. Period is 2 pi divided by the number in front of this variable. And this variable can be anything. It doesn't have to be an x. Interval is take the answer you got for this period and you divide it by 4. That's how far apart your tick marks go. Frequency is just period, the reciprocal of period. You take whatever the period is and flip it upside down. Phase shift is a horizontal shift. Now, you can take the C and change the sign to negative and put it over B here. Or you can set the inside part, this bx plus c equal to 0, and solve for the variable x. Vertical shift's the same as earlier. It's out here by itself, and that moves your x-axis up and down d. Domain's always negative infinity to infinity, and your range is whatever your vertical shift is, this value here, minus the amplitude, and the vertical shift plus the amplitude. That'll be your range. So we're going to go through and do some of these problems kind of quickly. I'm not going to use what I get, all that stuff on these first problems, but I am when we get to graphing them over here at this part down here. And I will probably let you pick a problem that you think is really hard down here. So this first part says we want to find the period and amplitude. Okay, so from our formula over there, the amplitude, which I'm going to abbreviate amp, is the absolute value of the A, and the period is 2 pi divided by B. Now, if you notice, this 2 pi, that's the normal period for sine and cosine. So we're taking the normal period and dividing by B, and B is the number in front of the x. Now, again, x could be a t, could be a theta, could be anything. So which one of these problems right here, because you're going to do all of them except number 5, which one of these would you like me to do? Yell out a number. Number 7, is that what you said?
I can't even see the point.
Okay, well, I'm going to write it up here. So let's see. 3/4 plus pi x over 2. Number 7 says y equals 3/4. I can't remember if it's sine or cosine because it doesn't matter for amplitude and period, but let's look. Cosine pi x over 2. All right, so we're supposed to find the amplitude, which is the absolute value of A, and we're supposed to find the period. These are the only two things we need, which is 2 pi divided by B. Okay? So, can anybody tell me what is the amplitude? Absolute value of what? Where does the A go? The A is always in front of the what? Trig function. So what is it? 3/4. What's the absolute value of 3/4? 3/4. The period is 2 pi divided by B. Where is B always located? In front of the x. Can anyone tell me what's in front of the x? Okay, that's close, but not quite right. When I write these problems, I take the x and I move it over beside this because this whole fraction is the B. So they may put the x in the top, but you may want to write it beside the fraction bar because B is actually pi over 2. It's everything except the variable. Okay? Now, what I do is I make this 2 pi into a fraction. So I have a fraction divided by a fraction. And what do you do with the bottom fraction to simplify? What do you do with pi over 2 to, what do you multiply by to simplify this thing so it's only one fraction and not a complex? So what of pi over 2? What? Reciprocal, that's right, because we want to get this to cancel out on the bottom. So you take the bottom and the top by 2 over pi, because down here these all reduce to 1s. Now this pi and this pi will reduce, so my period is 4. And we are done with that problem. Any question? How many are thumbs up on that one? All you good? Okay. All right. Let's go back over here and look. Then you get down here and you're supposed to tell what changed in these graphs. Okay? We're going to do one of the ones from 13 to 20, and then we're going to do number 22. Okay, we're going to do one of the ones from 13 through 20, and then we're going to do number 22. So you guys pick one of the ones through 13 through 20. 15, is that what I heard? Okay, 15. 15 says f of x equals cosine 2x. I'm going to add that up here. Nope, that's a different one. 15 says f of x equals negative cosine of x, and g of x equals negative oh, I lied. It said cosine of 2x. Okay, let's go over here and fix that. Cosine of 2x. Oops, I went too far again. All right, this is not there. And we check cosine of 2x. And then it says g of x equals negative cosine 2 of x. Now, what's the difference? What is the difference between those two graphs? Or the two equations? What's different? Anybody? There's a negative in front of the second cosine. So now let's have a flashback to what we did way back at the beginning of the school year with transformation. What happens when you make a function negative? Does anybody remember what that does to the graph? Reflects it across the x-axis. That's exactly right. So there's your answer. G is reflected across or over the x-axis. Okay, so what that means is, I'm just going to show you real quick, and this is, I'm not going to put any of the tick marks because we're going to mess with that later. So cosine starts at a max, goes to a 0, goes to a min, goes back to a 0, goes back to a max, right? And I'm going to take that back because I'm going to put that in blue because that's that one. So it starts at a max, goes to a 0, goes to a min, goes to a 0, goes back to a max. That's the cosine graph. So this negative would take this and reflect it down here to the minimum, and then it would hit a 0, then it would hit a maximum, then it would hit a 0, then it would hit a minimum. So this graph would look like this. It reflects the blue graph across the x-axis. Okay, I want to talk to you again about something I talked to you the other day about. I hope you remember that. If you hit a max and you go like this, you go above the max for the original, it's wrong. Just like if you go below the min, if you stop at a min and you go below it, that'll be marked wrong. You can't go below the mins, you can't go above the maxes. So if you do that, it's going to be a point off for you. So that's what that graph would kind of look like. Now the tick marks would not be our normal ones, but we're going to get to that again in a little while. Now I want to do number 22 because it's kind of a hard one. If you have your book, you may want to look at this, but this has, you know what? I could take a picture of this real quick and blow it up. Let's do that. I'm going to put it on the other screen. All right. Where's my page 304? Open up. All right, so that's a little better picture of 22. So if you look at the light color is the original graph, and the darker colors are transformation. So we want to talk about what changed in this. So I want to talk to you about how would you explain, or how would you characterize this darker color to the lighter gray color? What's different about it? Anybody tell me? Hmm? You can tell me. It's all right if you don't say it right. Yeah. What? The lighter gray spread out more. The darker one's got more humps, ups and downs, right? Does anybody know what that has to do with? The more up and downs you have, I told you on last Thursday. Anybody remember what that has to do with? Yeah, I just talked about a few minutes ago. On the light gray one, I'm at a max. I come down here and I go to a minimum, and I'm going to go back up here, and I hit a max back up here. What is that right there? From max to max. What is that called? Anybody know? That's a period. That is a period, right? So if you look at the dark one, if you look at the blacker one, it starts here, comes down here to a minimum, and comes back up here to a maximum, right? So the period is what in the black one compared to the red one? Smaller. It is smaller, right? The period's less. And as a matter of fact, if I kept tracing this, and I trace this all the way back to where it comes up to a max again right here, how many periods are in there? No. 1, 2, 3. 3 periods. Do you remember I told you that that's what the B is? I don't know if you remember that or not. So from the original graph to this new graph, this is cosine of 3x. Why did I put cosine? Anybody know why I put cosine and not sine? Where did my graph start? Max. Cosine start at a max. Where do sines start? Origin. They start at the 0, right? So that's why I put cosine, because it started at a max. So cosine 3x is this one. So what you would say is the period of this one is 2 pi divided by 3. The period of the original one, let's put red because that's what I drew it on, is 2 pi divided by 1. Well, if I take 2 pi times 1/3, wouldn't that equal this thing? So what we would say there is the period is 1/3. I guess I should say period of G is 1/3 the period of F. So the period's a third. So anything you wrote similar to this, you could say the B is 3 instead of 1, something like that. But those are one of the hardest ones. Periods and phase shifts are the hardest parts. Okay? All right, so that was number 22. Let's go back here and look. Now, when you get up here, you are supposed to sketch the graphs on the same coordinate plane, include 2 full periods. So we're going to do this. Pick a number, 25 to 30. We're going to put both graphs on the same plane, on the same graph. Anybody got a number between 25 and 30 you want to see? 27 is the one we're going to do. And by the way, it's in red, so you could do this barcode up here, and it'll show you a video of how they do it. It might be different to me, I don't know. But we're going to do this problem together right now. So number 27, did it have f of x? I don't know if it said f of x or y. I've been putting y. Yeah, it's got f of x and g of x. Okay, so it says f of x equals cosine x. And then it says g of x equals 2 plus cosine of x. All right, so I'm going to graph the, let me put this here. Okay, so amplitude is the absolute value of 1, which is 1, because there's a 1 right here, even though it's not there. Period is 2 pi divided by b. B is 1 because there's also a 1 right there, which is 2 pi. Intervals, those are my tick marks, are going to be 2 pi divided by 4, which is pi over 2. Phase shift. There is nothing in there in parentheses with the x, so it is 0. Vertical shift, there's no number by itself out here. It is 0. And I'm not really worried about frequency right now. So I'm going to graph this thing. Now, because the period is 2 pi I'm coming out here somewhere and putting a 2 pi right there. Because that's the period. Y'all understand where that came from? It's from the period. I'm putting the period down here. Then I've got to get 4 more tick marks, so you cut it in half. Half of 2 pi is pi. You cut that in half, and that's 3 pi over 2. And you cut it in half from 0 to pi, and that's pi over 2. And then you do the exact same. You try to get the same distance on this side, because we're supposed to do 2 periods, so that's negative 2 pi. Cut it in half is negative pi. Cut that in half is negative 3 pi over 2. And cut this one in half again, and that's negative pi over 2. So that's where my tick marks go. My tick marks, if you notice, pi over 2. Do you see that's pi over 2? And pi over 2 again would be pi, and pi over 2 again would be 3 pi over 2, and 8 pi over 2. You okay with that? Okay. Now, where's cosine start? Max. And the max is the amplitude. So that means the amplitude is 1, so I start at 1. Okay? Then you go from a max to a 0, to a min, to a 0, to a max, and you do the same thing the other way. From a max to a 0, to a min, to a 0, to a max, and then we make a smooth curve. Remember, if you're at a max, you cannot go above the max. Do not make mountaintops on these curves. If you make mountaintops on these graphs at the max and the mins, you're going to get a point taken off. You know what I'm talking about with mountaintops when you're a little kid and you used to make mountains? So if you do it, if you go like that, I'm going to put, if you like up here at one of these maxes, you do this, I'm going to put -1 mountain. You're not allowed to make mountains on these. They're smooth curves, not sharp curved turns. Okay? So that's the red one right there. Now we are going to come over here. I'm going to erase this stuff because I need more room. What part of that, what part is that 2 from the formula I gave you a little while ago? We'll just do cosine. What part is that 2 right there? So you say A? Is that what you said, A? That's what I thought I heard. Okay, so this says, in my formula that I gave you earlier, this says A plus cosine. Is that what that says, A plus cosine? No, so that's not A. A is multiplied by cosine. A here is still 1. There's a 1 right there still. Just like there's a 1 in front of that, the 1's still the same. It did not change. It is D. They mixed around the order. They moved the D from out here all the way to in front. This is the D value right there, and I'm going to change this to blue. So this means there is a vertical shift up 2 on this one. Because D equals 2. The vertical shift is 2. So what you do when you have a vertical shift is you take your x-axis and you move it vertically. Now, it's not really the x-axis anymore. Okay, so what you do is you take this x-axis, this is still really the x-axis, and we have to move it up here, and we make a fake x-axis. This is not really the x-axis. It's supposed to be going through that too, by the way. And we call this x prime. Now, if there was a phase shift, if I had a C in here, I would also have to move the y, but there isn't, so I don't have to worry about it. Okay? So now I'm going to graph this graph. So this is my origin. This is my origin, so I have to start at a max, 1 up, the amplitude up, which is 1. I go up 1. Then at my phase shift didn't change. In other words, my period is still 2 pi. My intervals are still pi over 2 over here. Nothing else changed. So here at pi over 2, this is now your 0 here. And then your min is still at pi, but it's got to be up 2 from the other one. And then you go back to your 0, which is really a fake 0, up to your max, and you do the same thing going the other direction. So this blue one is the blue one I've got graphed over there. It has taken the red graph and moved it up two places. Now I want to talk about domain and range real quick because the domain's the same for both of them. Okay, now your range, if you remember, we said it was vertical shift minus amplitude. Well, vertical shift is 0 if you remember. So since vertical shift is 0 and amplitude's 1, I get 0 minus 1, which is -1, and 0 plus 1, which is +1. And I hope you can see the top is 1, the bottom's -1, right? Y'all see it? And if I did the domain and range for the blue one, the domain never changes for any sine or cosine. But the range is now, you take the vertical shift as 2, right? Vertical shift, and you say minus a, vertical shift minus amplitude. So vertical shift -1 is 1, and vertical shift +1 is 2 plus 1 is 3. And I hope you can see that this graph is between 1 and 3. You see it? How many are thumbs up so far? All right. You may think this is easy. This is hard. Vaughn, you got any questions? You didn't give me a thumb. Paul, you got a question? You give me a thumb. Madison? Okay. We're going to go back. I'm going to do one more problem today, I think. Maybe more. We're going to do one of these here. I'm going to actually do one that we did last class. I'm going to go over to it. Okay, we're going to do this problem right here. All right, so they gave us that black graph up there at the top, the black equation. I rewrote it. Do you notice what they did again? They may do it every time. I don't know. They put the D in the front. So I rewrote it so it'll look like R. So sometimes they may stick the D in front. The thing that's going to tell you that it's a D in front is if there is a sign, if there is a sign between the number in front and the cosine, then it's a D. That's how you're going to know. All right, who can tell me my amplitude? You know, we're going to come down here and we're going to do domain and range also. I'm going to go ahead and fill in domain because it never changes on these. You know, I'm going to put my tick marks on and save those. 1, 2. 1, 2. Okay. Now, who can tell me the amplitude? 5. It's the absolute value of 5, which is 5. That's the amplitude. Period is 2 pi divided by what? Which is what? So I'm going to do this. I'm going to do what I did last time. I'm going to multiply this by the reciprocal of that. Most of the answers will have pi in here, by the way, but these don't. Okay, so 12 times 2 tells me my period is 24. So my interval is going to be 24 divided by 4, which is 6. So I can come over here and do my number line now, my x-axis. So in other words, I know this is 24 because it's the same as the period. This one is half of that, 12. This is 6 more. This is 6 less. And these are the negatives. You see that they're 6 apart, just like this interval says? Y'all see it, 6 apart? I hope. And again, most of the time, your x-axis will have pi's in it. All right, so, oh man, I guess I got interval up here twice, don't I? So let's put it down here where we got room. Phase shift. What tells me the phase shift? What letter's in the phase shift that we've not used yet? C. B we've used already, but C's the key. If there, do you notice up here, I rewrote this and put a C in here because there's nothing in parentheses. So this means the C is 0. So whenever C is 0, your phase shift is 0. So be happy when C is 0, because when C is a number, it makes it harder, quite a bit harder actually. What did I say frequency was compared to period? Reciprocal. This is 24 over what? How can I make 24 a fraction? How do you make any number a fraction? Put it over what? 1. So if I flip that upside down, what's my frequency? 1 over 24. What's the vertical shift here of this? -3. All right, let's do my range. Do you remember what we do to get range? We take vertical shift, what? So -3 minus 5. What's a -3 minus 5? And then -3 plus 5. So there's my range. Now you might see why I did my tick marks the way I did, huh? See, I went from -8 to 2 on them. I already knew that's what it was because I'd already figured it out in my head. Yes? Frequency is taking the period, which if you make the period into a fraction, that's 24 over 1. You take the period and you do the reciprocal. You just flip it upside down. All right, so let's graph this thing. I'm going to graph it in black. Now, this has a vertical shift of what? So I come down here to -3, and I'm going to draw a fake x-axis through here. This is my new x-axis coming right through here. And I'm going to call it x prime, x tick mark, whatever you want to call it. Mathematics, we call that a prime. It means all kinds of things in math. I wish I'd have made that parallel to the original x-axis. All right, and we are going, and if there was a phase shift, I would have to move this thing right or left somewhere, but I don't, because the phase shift is 0. Now, which graph we graphing? Cosine. Where does cosine start? At the max. Now, the max is normally 1, but this has an amplitude of what? 5. So that means we have to go up 5. We got to go up amplitude 5 from here. So I'm going to go up here to 2. I'm going to put a dot. There's where I start, that max of 5. Now, if this would have been a -5, I would have had to go down and start down here at -8. I'd have had to start at negative if that had been a negative, because it would reflect it across the x-axis. You just started at a min. Now, you go from a max to a 0, right? Now, you got to be careful here. The 0 is no longer here on this x-axis. It's down here on my fake x-axis. So I go from a max to a 0 to a min, which is 5 down from here. And then I go back to a 0 and back up to a max. It's probably a little too high. And do the same thing the other way. A 0, a min, a 0, and a max. Remember, your top should be in the same place and your bottom should be in the same y values. They don't change. So I'm going to make this into a graph here. It doesn't go back to the left like my pen just did. Come on, dude. Let's go handwork. If you notice, I am making hills at the max and the mins, not mountains. And I'm turning them down from the maxes out there to show they're going to go back down. So there's the graph. That's pretty hard stuff. You may think that looked easy. That is hard. And you better practice it from now to Thursday, because if you don't practice it, you're going to be in trouble. All right, let's go back over here and see if we want to do any more problems. Okay, that's how to do all these. This isn't doing anything. Oh, these have phase shifts. You want to do one with a phase shift? Okay, which one of these you want to do all the stuff, like 61 or 2? Which one you want to do? 62. It's a cosine. I kind of like to do a sine one. Let's see. Let me look at that other page. That thing's at the top there. I've got a picture of the top because it didn't come off when I did that. Here are these. What do these say? Describe transformations. Yeah, that's no big deal. All right. So you want to do 60 what? 1? 62. Okay, we'll do 62. You're going to see how hard this is when you do one like this. So 62. Anybody got a book open so you can read it to me? No? I don't know if it says y or f of x, doesn't matter. 62. 3 cosine, pi over 2 is and a minus 2. 3 cosine, pi over 2, x, can't remember if it's plus or minus, plus pi over 2. And minus 2. Okay, I'm going to put all these on here. Amp, period. Interval, phase shift, vertical shift, frequency, domain, range. Damn, I use this thing to cheat with. Now, when I draw this x-axis, do you see it's got a vertical shift down too? So I'm going to put this a little lower than the middle. Actually, I should actually move it up a little bit because I got to come down from that. So I'm going to put it a little higher than the normal. Okay, so I'm going to go ahead and put my tick marks. I need 4 of them. So I go there, halfway between there, halfway between, halfway between. Same, try to go the same distance out here. About the same. Yeah, close enough. That's why if you do graph paper, it looks a lot nicer. Okay, we ready? Amplitude, what is it? It is 3. You gonna make it, man? Can you stay with me? Yeah, you look like you're struggling. You gonna be all right? Okay. So the amp is 3. It's the absolute value of 3 is 3, period. 2 pi divided by what? So when I have a fraction, I go ahead and flip it. Because I don't have a fraction divided by a fraction, so this is 4. I kind of hate that these are getting rid of the pi's because the hardest ones to do tick marks of something else. So what do I do with that 4 to get the interval? 4 divided by what? 4, which is 1. That tells me this is 1, 2, 3, 4, -1, -2, -3, -4. Phase shift. Now you got 2 options. You can take this thing in parentheses and set it equal to 0 and solve for x. But I think it's easier just to change whatever this number is out here to a negative, which is negative pi over 2. And then you're going to divide it by b, which is that positive pi over 2. So we got to multiply by the reciprocal. So these 2's reduce, these pi's reduce, these 2's reduce, these pi's reduce. That is -1. So in other words, we're going down by 1's. -1, -2, -3, -4, -5, 1, 2, 3. Okay. Vertical shift, down 2. Frequency, take this period and flip it upside down, so it's 1/4, because that's 4/1. Domain never changes. Range, vertical shift, -2, minus amplitude, -2 minus 3, -5. And -2 plus 3, +1. First thing I'm going to do is put in my shifts. So I have a vertical shift down 2. So I come down here to -2, and I put a line going through here like this. That's my fake X. That's what I'm going to use. This has a phase shift of -1, so I got to move my Y over here to -1. So that's Y prime. Anybody got a question so far? The hard part is now done. Where does cosine start? Max. Now normally we take this origin and start right there, one above this fake origin. But my amplitude is 3. So since my amplitude is 3, I have to go up from here 1, 2, 3, and I got to start at 2. Oh, I went up too far. I went up 4. Go up 1, 2, 3. I should have gone up to there because this -2 is my deal. So -1, 0, 1 is 3 up. Then I go to a 0. Then I got to go 3 down. 1, 2, 3. I'm in. Back to a 0. Back to a max. Back to a 0. Do the same thing the other way. 0. I'm in. Back to a 0. Now, if you look, this is 2 full periods. Oh, I missed the dot. Okay, I'm going to come around and graph it. That's the end of it.